Hey everyone, just wanted to welcome you to week 4, module 4 for ME12 dynamics course. In this module, we're going to be going over Newton's laws of motion and equations of motion. So overview for this week, we're going to look at Newton's laws of motion and equations of motions for several different coordinate systems and how those apply. By the end of this week, you should be able to do the following. You should be able to state Newton's second law of motion and define mass and weight. You should be able to analyze the accelerated motion of a particle using the equation of motion with different coordinate systems. You should also be able to investigate central force motion and apply it to problems in space mechanics. Assigned readings for this week. Before you go through the lecture slides or start the quizzes or homeworks, please read through chapter 13, sections 1 through 3, and sections 4 through 5 to correspond to the different sections of the modules. Assignments for this module. Homework 2 is going to be due on the 28th by 11 p.m. Please follow the instructions online on Blackboard for submitting this, and the grading will be done according to the rubric. And there'll be quiz 4, which will be due on the 25th by 4 p.m. This module is going to be broken into two sections, Lecture 401 and Lecture 42. In our first section here in Lecture 401, we're taking a look at Newton's laws of motion, the equations of motions, and equations of motion for a system of particles. So within this here, objective is to write out the equation of motion for an accelerating body and to be able to draw a free body and kinetic diagrams for an accelerating body. So we'll go through how to do these in a couple example problems, take a look at how do we go from a free body diagram into our equation of motions, how can we use our summation of forces, summation of moments, and use all that information to develop these equations of motion. So activities within this section, we're going to take a look at some applications for these, look in more detail into Newton's laws of motion, Newton's laws of gravitational attraction, and some equation of motions for a particle system problems. So we'll go through those and again come up with those equations and then could do a couple of hand solutions to problem solving. For the second section of this module, what we're going to do is continue on with equations of motion, but now we're going to take a look at rectangular, normal, and tangential coordinates. So within this here, we're going to learn how to apply Newton's second law to determine forces and accelerations for particles in rectilinear motion. And we're going to apply the equation of motion using normal and tangential coordinates. So activities again here, reminder, we're going to be assigning homework 2. We're going to have a reading quiz as well that you guys need to complete. Go through a couple applications. Then we're going to go through equations of motion using rectangular Cartesian coordinates. And then a couple of equations of motion problems and samples and key equations for our NT coordinate systems. And then again, go through some problem solving. So I'll have my video solutions for these problems posted up, as well as my hand solutions posted as a PDF. So now let's take a look at Newton's laws of motion. For the motion of a particle is going to be governed by Newton's 3 laws of motion. So if you recall these from previous courses, we have the first law of motion, which states that a particle originally at rest or moving in a straight line at a constant velocity will remain at this state if the resultant force acting upon the particle is 0. For Newton's second law, if the resultant force of the particle is not 0, the particle experiences an acceleration in the same direction as the resultant force. This acceleration has a magnitude proportional to the resultant force. And the third law states that mutual forces of action and reaction between two particles are equal, opposite, and collinear. I've also included these same equation sheets that we saw in the last module. Great thing to still reference back to, so you'll have them right here in this video so you can reference back to these as you're going through your problem solving, lecture slides, homeworks, and quizzes. This is our first page here. All our key equations for kinematic relations, constant acceleration, position, velocity, acceleration, kinematic equations for horizontal and vertical motion, acceleration now in this NT coordinate system that we're dealing with now. We'll also have here, as we can keep moving on, our polar and cylindrical coordinate system as well. And then some specific examples here for radius of curvature, dependent motion, relative position, our law of sines and cosines.